representation of power series? I write so nicely. Is that what I heard?
Like on a smartboard, like.
Yeah. I dislike my writing on a smartboard, but I know that
it could be worse.
It's more legible than my normal handwriting.
Not much of a
Well, do you set the bar very high though?
No.
set the bar. Okay, so consider this as our function.
Consider
You're supposed to consider f of x equal to 1 over the quantity 1 minus x.
just do the quantity to the negative 1.
Now I don't know what that is. Okay, does this look similar to a formula that we maybe used a couple weeks ago?
Nope.
What? No, what did you say?
Say it.
The arcs
Never mind. I know where you're going. I'm there with you.
Yeah. It's a couple weeks ago. Back when we were doing
Not like
Oh, it's the geometric series thing.
I'm not there. That's the same
Oh,
thing.
wait,
that's
I
clever.
see it.
That's really clever.
Do you see how those two can be? I guess. Do you see how this is modeled like this formula right here?
So where do you say A equals X
No.
again?
So 1 over 1 minus x
Oh.
could be written as the sum from n equals 1 to infinity of, what would A be in this case? 1. And what would R be? So A times R to the n.
Wait, why is RX
Because they're not they're in the same class. Okay. So this power series is what you plug in. You have
Why doesn't n to 0? Like for your signal.
I don't know, it should. That's what I was contemplating just now, and then she interrupted my train of thought. So this is 1 plus x squared, blah, 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 blah. What do we know about R for this formula to work? So the absolute value of it has to be less than 1, right? Okay, so that doesn't change. Since we use our geometric formula to write this, we know that our rate, that the R, our common ratio, the absolute value of it has to be less than 1. So we automatically know that our interval of convergence is -1 to 1, and we don't have to test our endpoints because this is geometric. The endpoints are not going to converge because our common ratio can't be 1. Now, another way to get from here to here would be long division. Don't have to write it down. Let's just take it.
Hey, ring,
Brain break.
My brain's always hungry. I don't know how to function.
Okay.
Right.
Oh, hold
like they have this difficult and concerning that maybe two different words between the red and the black. Tackle and who's
Who are the actors in Calc BC?
People that they've been in.
people
Are
that
they
have
like actual like
Well,
actors?
maybe they don't have to be.
this year they bring Denzel Washington.
Okay, 1 times what is 1?
Yeah.
1. Okay. So what do we get?
-1.
1 times what is x?
X.
What is that?
We multiply and subtract. 1 times what is x squared? Make you see what this is doing?
Wait, why is it
Why are you dividing it 1 by 1?
Well,
Oh, because it's 1. Okay.
yeah.
Okay.
So then this is just going to keep going. Okay?
Forever.
Forever. Which we can model as the infinite sum of x to the n. Okay?
Forever.
All right, which one's better? Do you want to use the geometric shortcut or do you want a long divide? Geometric shortcut, right? Okay. All right, so what if I gave you 1 over 1 plus x cubed? You don't need the question marks. I'll just use the inflection in my voice. What if I gave you 1 over 1 plus x cubed? Is it? Could we write it so that it looked geometric? Could we write it as a over 1 minus r? It is still modeled as a over 1 minus r. So this would be the infinite sum of a times r to the n. But I would suggest making this look a little bit nicer. Okay, this is probably how you would probably not see it like this in any sort of question presented to you. What? Okay. A negative to the n, they're always going to separate. So you would probably see it like this. It's an alternating series with x to the 3n. Okay. Now, was this modeled geometrically?
No.
We didn't use a over 1 minus r?
Well, yeah.
Yes, we did. Therefore, we know the radius and interval of convergence without having to do any work. Okay, where's this centered at? 0. We want r, the absolute value of r, to be less than 1 in order for this to work. So we know that our interval of convergence is negative 1 to 1 without having to do any other ratios.
So,
Yes.
why did you read that? If you can just go straight from that first one.
I rewrote it so it looks more presentable. Okay, if you have a negative to the n power, they're gonna want to see it as an alternating series. Okay, the negative 1 to the n gets separated from the rest.
Well,
Why couldn't you just go straight from the black into the
You could.
You could.
That's just so we see R. No. Like you changed it to the blue.
Yeah.
Why didn't you just say, okay, so the absolute value of negative x cubed is less than 1, so it's negative 1.
Yeah, I showed you the interval, but you still need the power series.
Why do you need the power series? It gives you any. You know what I mean?
Okay,
It didn't help.
so maybe you're missing the. Maybe I did not make this clear. We are taking functions and we are writing them as a power series.
Oh.
Okay, so that's where I didn't communicate.
That's
to you
part
what
of
we're
the
doing.
answer.
So this is the answer. This is the power series. Here is its interval of convergence without having to do anything. Okay, you are right. Okay, now I want a power series for, that's a 4, this guy. Oh.
And so we have to separate the 4.
Okay, so first of all, I want it centered at -2. So that's the first thing that we have to take into account. Right now, like if I were to work with this, since this is just x by itself, we would be centering at 0. But if we want it to be centered at -2, we need a quantity x plus 2 somewhere. Can I just add 2 to the denominator? Okay.
You gotta add 2 to the numerator.
Adding 2 to the numerator and 2 to the denominator means I'm adding 1 to the value. And that's not okay either. Okay? So, what we're going to have to do is if I'm going to make this an x plus 2, what number did I really just add to the denominator? I added a -2. So to counteract that, I need to add 2. Right? However, this does not look like a over 1 minus r. This is a problem. That needs to be a 1. So we're going to need to multiply numerator and denominator by 1/7. Okay? We're multiplying by 1. Multiplying by 1 does not change anything. We just change how it looks. 4/7 over 1 minus x plus 2. Very easy. What? Okay, so let's talk about the representation. F of x would be the infinite sum of a times r to the n.
Oh,
Cheesy breadsticks is a bad one.
That's not it. It's not good.
My son likes it.
Or you can just do.
My son doesn't complain about his hot wings.
Tuesday,
Or you can just
Thursday,
do what I do,
Friday.
just not
They
eat
teach
one.
these kids is good up until 2nd grade.
Ask your son about like the regular cheese sticks. He gets the yogurt cheese stick. Ask him how those are. I want to see. I want to know if like they still have those. You know,
that's what I got. Every
Like
day.
string cheese?
no, it's
No,
like
like
a
you get the
yellow.
alternative one. But
Yeah, he'll sometimes
Yogurt.
get yogurt.
and
Does he eat the cheese?
I'll ask him now.
Yeah.
I mean, I think so.
We put it. They can not eat
Okay.
cheese. So.
So
Then you ate
technically this is fine. Technically this is fine. But sometimes you see like the center raised to the power all by itself. And since this is 7 times 7 to the n, you could write it as 7 to the n plus 1. Like if this were a multiple choice type question, this is how you would see it in the answer. because this 7 is not to the n. This 7 is just to the 1. Okay. Now, our interval of convergence. Let's first talk about our radius of convergence. We know that this is our common ratio right here. And our common ratio, the absolute value of it needs to be less than 1. So the absolute value of x plus 2 is going to need to be less than. So if I come over here with this. So our interval of convergence, from -2, we're going to go up 7 and down 7. Okay.
It's centered at 2.
-2.
Oh, there you go.
Got it?
No, I haven't looked ahead this time.
That was good though.
That was good. No, that was solid. That was a good one.
What operations are allowed when you're working this out? I'm going to tell you.
The one that
Yes, it
you're
is.
gonna tell us.
If something's multiplied inside, you can apply it. It would get the power because it's with x. And really, it'd be kx to the n, but they've separated it out. Really, we could plug kx in for x, so it would be kx to the n, but they separated it out. Same thing with a power. If you have x raised to a power, then that can be substituted in, and it would also get the power. This is how the book did it. I'm just trying to be consistent with the book. Do your capital N's and lowercase n's look the same?
If I'm in a rush, kind of.
Like one's curved and one is straight line. I really don't see how
That's
that
kind
could
of
be.
looks the same. One has one thing and one has an extra
Yeah, but it's like smushed together like my hand.
I actually got that.
thing. You know what I'm saying?
Yeah.
Like, I
That's
know,
amazing because he said thing and you
I-
understood what he was
the
talking
thing
about.
is, I know exactly what he's talking about, but still, what?
I don't know what else there is.
The extra thing.
That's it.
It's got that extra bit of it.
We could add or subtract power series together, which means inside the sequences could be added or subtracted together, multiplied to the x to the n.
So we never get bored with math.
Math keeps me on the toes.
We never like taught how to do this again.
some lessons that I like more than others. I will be honest. Like I get really excited when we get to work with clear identities. I think that that's a really fun read. I love it. Yeah, integration by parts is another. I love that lesson. Yeah. Yeah.
What's your least favorite
My least favorite.
out of all of the classes?
What least favorite lesson?
That's really good.
Riemann sums.
What?
Whoa,
Remon's
those
on.
are the words.
I don't like that lesson.
That's a critical point in our project.
Exactly.
Yeah, it is.
It's how you get it. You need to get an intro.
It's just a lot of buildup.
And then like,
a lot of
and
building
then-
because you're not going to use it live.
Well, I mean, it's an important concept. There's a lot of little details that is just, it's not my favorite thing to teach. I'm not saying that it's not important. It's just not my favorite thing to teach.
It's like a lesson doing
Or doing the.
Okay, so let me show you what we can do here. Do we have a power series representation for 1 over 1 plus x cubed? Will you look at your notes, please?
yeah,
Like, wasn't that example number 2?
yeah,
1 over 1 plus x cubed?
yeah, it was.
Thanks.
It's 2x squared on top. Yeah,
Isn't that cheating? Yeah, like I understand.
Like, they multiply, right?
Yeah, I know. it just
So we
sounds like-
know that we can write this guy. What did we write him as? Negative 1 to the n, x to the 3n.
yeah.
That's what we did in example 2. So then we can squish it all together. I multiplied the 2 in. X squared times x to the 3n means we add our exponents. Algebra 1 coming in strong for us.
Oh my goodness, no, this year really?
Nick, what's our interval of convergence? Is it this? Does this 2 have any effect on our common ratio? Yes. Because we're still grabbing this guy for our common ratio, whatever is right here in that fraction. Okay. Now, one of the properties I wanted to talk about, so we know that 1 over 1 minus x would be the series of x to the n. Because a is 1, r is x. So if you have 1 over 1 minus x to the 50th,
That's it. 50.
we just x becomes x to the 50th to the n. I don't need a parentheses. X to the 50n. X to the sun. Okay. We're going to do a lot more with that next week when we talk about Taylor series. But you talking about Taylor polynomial. Yeah.
I almost did a big mistake there.
Okay, we'll come back to a partial fraction one if we have time, but I want to make sure
No,
that
it's
we
alright.
go.
To be a teacher, you take more like, be a math teacher, you have to take like a lot of upper, like higher level math lessons, or is it more like how to deal with student stuff?
I came out of college with a math degree with a few education classes. Same with my master's. I have a master's in math education, but it's really a master's in math with a couple education.
Is that how like most teachers here are?
For to be a secondary education, so to be a secondary teacher, so 7 through 12, you basically take a lot of classes in your area, and it's almost like a major in the area with like a minor in education is kind of how it feels.
Do you ever still use some of those like higher level classes? Not really.
I mean, once you get to the theoretical math, there's a bunch of different things, but abstract algebra. My last class was called in college. What was it called? I don't remember now. Something calculus.
What was the most?
It's all theory, like number theory, abstract algebra, all of those things. And then you just keep taking more classes based on that. Like I've taken like 3 different abstract algebra classes, linear algebra, stats, theoretical stats. What?
What was the hardest?
I don't know. They were. I mean, all the theory classes were difficult, but equally difficult, I thought. Which one did I dislike the most? Computer science. Okay, so this does not look like 1 over, or a over 1 minus r.
You can distribute it. You can distribute it through both.
But then it's 1 minus 2x plus x squared.
You know, like this.
But how is it related to 1 over 1 minus x?
Square root of the top and the bottom.
We'll just make it 1
Okay.
over 1
Can we
minus
think like calculus for a moment?
As I said, it's
Derivative.
Derivative.
Ew.
It's the derivative of what?
Oh my god, that's
Derivative.
no, because there's no negative.
No, you are right.
Oh.
I am.
But there wouldn't be, yeah, because it was.
Because you do the -1 power,
And then it cancels out the -1.
but then it cancels out with that one. Okay. So, well, what do we know about this power series? It's
Geometric. And its interval is -1 to 1.
okay. We know it's that, right? So we can take the derivative of that. Advanced calculus. That was the last class I took. It was basically like theory of calculus.
You have to like write
like fundamental theorem.
You have to do
No, I did have to take a history of math class. That was very interesting.
Did we learn all these guys?
Not all of them. Like I did a presentation about
yeah.
the number pi, and we did like and
2 pi, which
Did you bring in?
no, like the history of pi. Like I
That's cool.
like Like pi is referenced in the Bible. And
Wait, what?
Yes.
What?
Yes.
Where?
Somewhere
Caleb,
it's
wait,
referenced
don't say
that
Caleb,
like
where?
I don't know.
it is referenced somewhere in the Bible that like the ratio of circumference to diameter is about 3.
That's
Do you think
that
he
is
was
super
describing
cool.
the dimensions of the arc?
And then he was like, trying
Yeah.
to
No,
no,
run.
Okay, go look it up. So what's this derivative?
Definitely doing that right now.
N x is the n minus 1.
This is like wisdom.
Good. But we do have to adjust where we started. Right? We took the derivative, so now it has to start at 1. That's a big deal that I will take off points for. And I did on your quiz yesterday.
Wait for what?
When you take the derivative, since it's x to the n,
I did do it.
and then when you take the derivative n x to the n minus 1, you have to adjust where it starts, otherwise you're starting at a
I'm
negative
pretty sure
exponent.
I definitely did that.
Because I remember like,
Wait, are they in the grade book yet?
Wait, I'm confused.
No, because you had to turn apart into grade.
Oh, that is right.
Yes.
I didn't know if you were gonna like make those
I did
separate.
grade them, but I wanted to smooth it.
yeah. Oh, I did, because we only had one question like that.
I also disliked my 400 level stats class, but that was more because my professor was really mean to me.
Oh,
So, yeah.
let's get him.
I don't
We
even
will
know.
track him down.
I don't think he works there anymore. Like, I think he would have,
It's
he
still not
had to
secret
have
service
retired
number.
by now. I've been teaching for 12 years, and he was an older gentleman. But.
How is he?
Oh, so, teachers sometimes ask you to participate in the lesson by like offering suggestions, or, he asks a question and answer. He told me a couple times that I was stupid.
Wow.
Oh.
Who would have thought?
Like, yeah. Appreciate your high school teachers who are nice to you.
She would have just said like this.
Yeah,
She was like,
insist that you are stupid.
like the words, you are stupid.
Now, I did get an A in the class, so I feel like I proved him wrong. But he didn't like my suggestion a couple times.
Did you say like that was stupid, or did he said like you were stupid?
Both. That's 2 different occasions. I know.
That's
He really
horrible.
covered all his bases.
Hey,
Is that why we can't use
I'm
that
a-
word in here?
no, I don't like the
you
word
guys
in
say-
general. I don't think it's a word that should be used. How am I going to write a power series for this guy?
Hey, it's the integral.
E to the integral. E to the
The antiderivative.
Dang it. I really like the E to the natural one.
Do you agree that this is true?
No, because it doesn't have
Then I squeezed it in, don't worry.
Should I read pi from the Bible now? For the wisdom?
Can we please finish this? And I'd love for you to write it down. Okay, so the antiderivative of this side is
natural
You wrote it down.
I know, it's over there. Okay.
Why is there an
Yeah, there's
A?
supposed to be a kind of puzzle.
Hold on.
That would be.
What is this? If we were going to do that power series.
Yeah.
What do you think?
We'd have to change. We'd have to do the 1/5 thing.
Yep.
Multiply by.
So this would be 1/5. So let's just go ahead and do that. So I have to show all of my work, right? It helps to like be
Oh,
flowing.
He's getting.
You're the one. You're the one who
He's
told us about
increasing
it.
his spiritual knowledge.
Yeah.
This is science class. We don't
The
have to
integral
do
of summation.
Did I say science class?
It's alright. It's alright. It's alright.
Geometry.
I mean, technically math is just a language.
Okay.
Yeah, it's kind of a science.
So this is just a part.
Yeah.
That's pretty cool.
So we need to take the antiderivative of this power series.
How do you do that?
You've also done this on your yes.
1 over n plus 1 and x to n plus 1.
Oh, we did this on the take home part.
But you do need to make it negative because remember we have that negative relationship on the other side.
And the circumference divided by that.
The definition is fine. Good to know.
And you got rid of that.
Yeah, but it technically is wrong.
Wait, what is
It said say 3 or roughly 3.
But it says
It doesn't. I'll read it for you.
Yeah.
Wait, what is
Where is it? What's
It's
what
1
is it?
Kings 7:23.
Okay.
this
It
negative?
says,
What is it?
and he made a molten sea 10 cubits from one brim to the other. It was round all about, and his height was 5 cubits, and a line of 30 cubits did compass it around it.
Of 3?
So like 30 is the circumference, which
Oh,
would
that's
make
pretty-
5 3 because of that.
That is so cool.
So
Okay.
where does the negative come from?
where does the
Yeah,
negative
where
come
does
from?
it- Negative
Remember we have this relationship.
Yeah.
So if I want the natural log of 5 minus x, we have to have that negative on the integral.
Oh.
Oh, see. So it's a go.
So you do
You
need
gotta
to
think
see
way
back to
backwards.
that,
The introduction.
Technically, and we can find the c.
because I didn't do that one.
I didn't ask you to. This is like one of the rare times where you're actually going to get a c value. When we put in x is 0, what would we get? Well, like here.
Roughly, and you would get roughly 3
This is what it equals, right? So if x is 0, I have the natural log of 5 over here. So this is the natural log of 5. This is like one of the rare times you would have a c value that's not 0, and mainly it's because we're working with the natural log of 5 minus, like, since we're working with the natural log of 5. Okay? But I'm pretty good if you did the
What happened to
That's
that?
kind of. What are we doing now?
What?
What are we doing now?
I just found our plus c. If I plug in like x is 0 to all of my x's,
Yeah.
this is 0, and I get c equals the natural log of 5. So I just solve for c.
But where'd the x?
It's because of X is. The whole other thing is X.
Wait, and
So I think like x is 0 means
I thought the 5 if you were an x log of 5 minus x was 5 over x.
So like if
So
I
then
plug in
that's-
0 to both sides, I solve for c equals the natural log of 5. And so then I plug that in. But what I'm really concerned with you is getting the truth. I'm really not, I don't want to think about the rest. Okay? Just a constant. Okay? I will not worry about our partial fraction one because it's not pretty anyway. I don't, Caleb, I truly believe that you would hate that example.
Of what?
The example that I would do.
The next one?
Yes.
Why? What's in it?
You would just complain a lot.
Okay, but that's all math.
Doesn't Caleb just do that?
Everyone's thinking shop.
That's a broken bill about it.
Oh.
Okay, are we really taking shots now, or are we just stating that they do that?